This is the official definition of what is a nano system. As I have said, the dimension has to be less than 100 nanometer. And why this magic number 100 nanometer? I'll give you an example which will justify this number. Otherwise, you will say that why not 50 or why not 200? There is a logic behind this 100 nanometer. Okay. We need to have a, when we do a synthesis, see, for using nanotechnology, the first thing that one needs to know is one needs to have the right nanomaterial. And then once you identify the right nanomaterial, you need to synthesize it, make it. And I'm telling you that if you make it yourself, the cost is going to be very, very low. Number one. Number two, you know what you have made. The commercially available nanomaterials are many times very, 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 their properties are not very well known. The synthesis conditions will not be revealed to you, and many things are hidden from the user. They use many processes and controls during the synthesis, which is not available to the user. So user many times doesn't know what he is dealing with. So the best way is to synthesize one's nanomaterial in the lab, and it's not rocket science. One can make the nanomaterial himself. And as I go along, and I'll give you different methods of treating industrial effluents, I will also tell you how to synthesize the nanomaterials yourself. You don't need to buy it, and it can be done by following very simple 4 to 5 steps, and can be done in any lab which has got the basic chemistry infrastructure. Okay, next, using these nanomaterials, we should be able to make superstructures or assemblies, conjugates, higher order structures. So once we satisfy all the conditions, then we are sure that we have a nano system and we are working with a nanomaterial. Wonderful. Now, why nanomaterials become so active when the size becomes smaller? Okay. Now see, suppose there is a microparticle which has a dimension of 60 micrometer, a ball of 60 micrometer diameter. Let's say I have a mechanism to break it to 600 nanometer diameter particles. It will give rise to something like 1 million particles. Further, I break it down to 60 nanometer diameter particles. I'll get 1 billion nanoparticles now. 1 billion particles. The size has become less than 100, so I'll call them nanoparticles. There are 1 billion nanoparticles. What has happened in this process? What has happened is, when you see the microparticle, it has certain surface area which you can calculate. Now you take 1 million particles of 600 nanometer diameter and calculate the surface area. Similarly, calculate the surface area of 60 nanometer diameter particles, 1 billion of them. You will find the surface area has increased drastically. Huge amount of increase in the surface area. When the surface area increases, the interface between the nanoparticle and the material with which you want it to interact, that increases, because that is the basic principle of interaction. Larger interface area, stronger interaction. So nanotechnology is based on this basic principle of a surface activity of the material getting enhanced when the size becomes smaller, and this is what is given a name which is called the aspect ratio.
For more updates, subscribe to our channel, click the links shown on the screen to stay connected.